When a forester assesses your woodland for developing your management plan, he or she will systematically collect information on each unique stand of trees. This information will tell him the condition of your woodland and help guide the development of specific practices to meet your desired goals. The mechanics of this inventory are beyond the scope of this short course. Besides, that is why you are working with a professional in the first place. However, if you can count, have a penny, 37 feet of rope, and a 2-inch 2x4 block, you can conduct a quick assessment that will assist you in understanding the report your forester will prepare. Ready? Let's begin. A forest stand must have a sufficient number of trees to efficiently use the available growing space. Very dense stands grow slow, while low-density stands do not fully use the productive potential of the site. Stand density is a way of measuring crowding between trees and may be expressed as trees per acre or basal area. These two measurements can then be used to determine whether the stand is overstocked, which means too many trees, fully stocked, just the right number of trees, or understocked, which means too few trees. Sampling is the key. Except for high-value trees such as walnut or high-value product grades such as veneer, it is not practical to measure every tree in the stand. Instead, accurate measurements are made on a number of sample plots, and this information is expanded for the entire stand. Depending upon stand conditions, the type of information sought, and the desired accuracy of the estimate, the forester will develop a sampling strategy for each stand in your woodland. This sampling strategy presented here is oversimplified, but you'll be able to collect some basic information with reasonable accuracy. To obtain a good estimate, sample plots must be located throughout the forest stand. The plots can be any shape, but circular plots are most commonly used. By collecting information on a 1/10 acre plot for every acre in a given stand, you will have conducted a 10% sample. This level of sampling is a good start for the beginner. How big is a 1/10 acre plot? It is a circle with a radius of approximately 37 feet. You can use a walking stick as the center of the plot and mark off the area using a pre-measured length of rope. At several points around the perimeter, mark the plot boundary with flagging on trees or scuff marks on the ground. To estimate the number of trees per acre, simply count all trees greater than 2 inches in diameter at 4.5 feet above the ground. If you are taking 1/10 acre plots, then multiply that count by 10 to get trees per acre. The diameter of a tree at 4.5 feet above the ground is commonly referred to as diameter at breast height, or DBH. The reason why we did not count trees less than 2 inches in diameter is because these individuals are considered belonging to the next forest, and in all likelihood will not significantly impact the growth of the larger trees. An easy way to decide whether or not to count a tree is with a 2-inch length of 2x4. Simply hold the 2x4 block up against the tree trunk at 4.5 feet above the ground and count it if the diameter is larger than the 2-inch width. The basal area of an individual tree is the area of the flat top of the stump if the tree were cut at 4.5 feet above the ground. The basal area of the stand is the sum of the basal areas of the individual trees. Basal area is expressed in square feet per acre. A well-stocked hardwood stand might have a BA of 60 to 100 square feet to the acre. Foresters have at their disposal several expensive tools for determining stand basal area. But for quick assessments, a penny can do the same job. To determine stand basal area using a penny, follow these 5 simple steps. First, stand at the plot center and pick out an easily recognizable tree. Second, hold the bottom edge of the penny between 2 fingers and aim it at a spot on the tree at DBH. Make sure to hold the penny 25 inches from your dominant eye and close your other eye. Third, count the tree if the trunk is wider than the penny. Fourth, repeat this test on all trees within your view by rotating around the circle until you return to the tree you started with. Do not count a tree if its trunk looks narrower than the penny. If the tree's trunk is the same size, then count every other tree. The fifth and final step is to multiply the number of countable trees by 10. For example, if you counted 9 trees on the plot, the stand basal area would be 90 square feet. Measure the basal area on several plots in the stand and calculate an average stand basal area. Having determined trees per acre and stand basal area, you can now use a chart like the one shown here to determine what foresters refer to as stand stocking level. Stocking level simply answers the question, do I have too many trees growing in my stand, just the right number, or too few? The mechanics behind the construction of this chart are way beyond the scope of this short course, but I wanted to make you aware of it so you are not overwhelmed when your forester shows you the chart and uses strange jargon to describe your woodland. Using a stocking chart, a stand can be described as being overstocked, fully stocked, or understocked. Stocking charts relate basal area per acre, average stem diameter, and the number of trees per acre. The basic premise of the stocking chart is that as trees grow larger in diameter and crown size, there will be fewer trees per acre. Stands that are stocked above the so-called A line are overstocked. In this situation, the stand will grow slow because of competition for sunlight, moisture, and nutrients. Although many of the surplus trees will eventually die, it is a slow process. Overstocked stands should be thinned to increase tree growth on the desirable trees and to improve forest health. When stocking falls between the A and B lines, the stand is considered fully stocked. Trees make their best growth when stocking is at this level. When thinning, stocking levels are usually reduced to the B line. Stocking between the B and C lines is understocked. There are not enough trees present to utilize the full growth potential of the site. When stocking is near the C line, it will take about 10 years for trees to grow to the B line. For example, in your assessment, you determined that there were 200 trees per acre in your stand, and the average basal area was 88 square feet. Moving vertically up the 200 trees per acre line and horizontally across the 88 basal area per acre line, the intersection falls between the A and B lines. Your stand would be considered fully stocked. Your forester could use this graph to also say that the average tree diameter is estimated to be 8.9 inches. And if the stand was thinned to the recommended B line, there would be approximately 130 trees remaining after the cut. As stated at the beginning, my intent is not to make you a forest inventory expert, but merely empower you to start seeing your forest for the trees. Part of seeing the forest is observing the relative mix of tree species. While you're counting trees, take note of the kind of tree it is. Does one species in particular dominate, or is it a fairly even mix of several species? What about tree health? Are there dead and dying trees present? If so, is there any pattern to the mortality? How about your future forest? Is there good advanced regeneration of the desired species, such as the oak seedlings in this stand? Or are there any invasive plants taking hold on the landscape, like the bush honeysuckle in this forest stand? Last but not least, how about the stand's wildlife habitat potential? If you desire deer and turkey, are there sufficient hard mass producing oaks present? These quick assessments will give you knowledge. Armed with that knowledge, you'll become more comfortable talking with your natural resource professional.